We were ready to last week's school, so this I don't know how old she is, but I guess she's in her 20s now. But she just looks like she's intensely enjoying herself while playing one of the hardest songs ever, the final boss of Guitar Hero 3. Okay, so today we're going to be talking about science, and Kearney, don't say that. I mean, you can always fail the class and take it again next semester. That's an option. So we got today and Wednesday, and I guess Friday. Friday's consultation days, but I'll probably be here recording a final review on Friday. So just show up on Friday if you want. I don't want to run the final. But you guys are always welcome to stay on the Discord. There's, we have people on here that graduated years ago that still hang out and post memes and do gaming with us and stuff like that. So you're most definitely not kicked off Discord after all this. So so let's get going on science. So there's this guy named Kuhn who wrote a book called The Structure of Scientific Revolutions, and he said that science doesn't really progress the way that we think it progresses, right? Like, sort of every year, science advances, and people write papers on it, and the boundaries of science are kind of always rolling forward and things like that. But he said if you haven't done the essay, it's too late. He said that's not always the case. Like, for example, if you look at Roman cement, we lost the ability to make Roman cement, right? Like, after the fall of the Roman Empire, one of the reasons why people sort of misleadingly call the Middle Ages the Dark Ages is because some technology was lost after the fall of the Roman Empire. Some of the recipes for making cement were written down, but the crucial ingredient, which was volcanic ash, was not. So when people tried recreating it in the Middle Ages, they couldn't make cement, and so it was lost. And so we don't always move forwards. Also, sometimes science will pursue a certain avenue of research without turning up any actual evidence for it. For example, we've been working on string theory in physics for, 20, 30, 40 years, something like that now, and haven't had a single bit of experimental evidence to confirm or deny that the universe is made up of a bunch of tiny vibrating strings. So maybe that's a dead end, maybe it's not. We don't know. So people just keep investigating it, and maybe someday it'll turn out to be true, or maybe someday it'll turn out to be false. We don't know. And that's kind of Kuhn's take on the linearity of science, right? It's like, it's not like we're just, it's not like in a video game where you like put your research beakers into science, and your science score kind of goes, it fills up, and when you get a certain number of research beakers, then you advance to the next technology or the next technology level or something like that. You can't see this? Oh. Okay, that's fair. One second. Alright, there we go. How about now? Yeah, I guess when I closed out of the video, it closed the streaming. There we go. Alright. Science rules, yeah. Alright. So, you didn't miss very much. There's just two bullet points up here. We do accumulate more knowledge over time, but sometimes we lose knowledge also, and sometimes we believe things that are false, and sometimes science gets really fixated on something that later on turns out to be false. For example, phlogiston is a explanation for fire. The luminiferous ether as the media for light to travel through, which turned out to be wrong. And what happens is that, Kuhn says, there's false starts, like I said, but you don't know they're false. Like right now, like string theory might turn out to be false theory. We don't know. You just have to work on it for a while. You can see with like the whole COVID-19 pandemic, you could see it in action, right? People had all these different ideas. does what was the name of the drug? Clorox. What was it? Was it chloroxyquinolone? What was the name of it? It's one of the quinolones that Trump touted as hydroxyquinolone. Sorry. Yeah. So, Trump was pushing hydroxyquinolone as a cure for COVID. And that didn't come out of nowhere. There was a French study, preliminary French study that showed that it was efficacious at reducing the time in ICU for COVID-19. And so, and so science was like, all right, well, we have a preliminary finding, so let's explore this. And so a number of research studies were done on hydroxyquinolone, and probably it doesn't do anything is the best guess that science has right now. We'll probably know more in a few more years. But here's the thing: it's like when you're in a pandemic, you don't have time to wait for the research to come in, because it's like, all right, do you take it or not? Ivermectin is the big thing that people are arguing over whether it's effective or not, and there's research studies that show both ways, and we don't know yet if it's and people are making fun of Joe Rogan for taking a horse dewormer. He didn't take veterinary medicine; he took actual human ivermectin. But we don't know actually if it works for sure or not. I've seen papers both ways on it, right? So, we don't know, and that's what makes life so challenging, is that you don't have that real certainty and confidence that people want to have. Like, people want to be certain about things. Like, does this drug work? And yeah, a lot of times you just don't know. You do a study, sometimes it agrees with what we believe to be true in science, sometimes it doesn't. Friday's like office hours. No, I'll just do a final review on Friday. So, same time as usual. But my consultation hours will be through noon or something. So if you guys want to hang out afterwards and ask questions, you can go for it. So when will the tests be open? It'll be open for basically all of finals week. I think Monday through Thursday, something like that. And so you'll have a big window to take the test in, and once you start it, you'll have plenty of time to do it. It's not going to be it's not like a time attack, final. I don't want it to be such a long time that you'll just sit there and Google forever every question or something like that. So it'll be like the midterms, basically. All right. So, yeah, it can be tricky, right? Like you might do a study on if orange juice causes cancer or something like that, right? And you might get a result saying yes, orange juice causes cancer, and then somebody else might do a study on if orange juice causes cancer, and they might say, no, it doesn't. And another one might do a study, and that one might say it actually reduces cancer rates. We would really like for, all the scientific results to point in the same way, right? That'd be really, really nice. If just like every time we did an experiment, we all got the same answer, right? And unfortunately, no. It unfortunately doesn't work out that way. Some fields maybe, but if you're talking about medicine, if you're talking about psychology in particular, there's so many confounding variables. It's very hard to tease out just one, let's say you do a study on if walking reduces your chances of cancer, right? Well, there's a problem, which is that if people get cancer, they might not want to walk, right? And so at the end of the day, you might be like, all right, we're going to graph on one axis how much people walked, and the other axis how much cancer they had, and it'll show an inverse relation, right? Like people with cancer don't walk, people who walk don't have cancer, but which fallacy is that? You want a 24-hour test? 3 hours, I think, is plenty for 30 questions. 6 minutes a question. Circular reasoning? Maybe a bit of that. But I was going more for the correlation's not causation problem, right? So just because you can correlate walking with not having cancer doesn't mean that walking causes you to not have cancer. And it's so tricky to tease out those things in health, and it's very hard to control because you usually can't like lock people in a jail cell and like force feed them orange juice for 5 years, and see how many people develop cancer. In education, you can't, force students to, sit in an isolated environment where they don't talk to anybody else. They don't have access to any other source of knowledge except for, a canned video feed explaining scientific revolutions, and be like, all right, look, if you play a high energy drummer at the beginning of class, then students will learn better, or something like that. Like, it's difficult. It's just really difficult to do science well. And some fields like particle physics, where you just sit there and shoot particles at a target, like, that's one thing. But you're looking at humans. Humans are complicated, So, so basically, I talked about this before, but what we do when we have a bunch of competing papers is we'll end up doing something called a meta. Like we'll do a survey and then we'll kind of do a meta study and sort of say, all right, which of these papers were high quality, and of the high quality papers, let's aggregate all of their data and then do a study of the studies. And sometimes people will do meta studies, and you have to make sure you're doing those right, because what if you're excluding good studies that just happen to disagree with you? It's it's very tricky. And so meta studies have to explain in a lot of detail, like what we used, what are our inclusion criteria, what did we use to include papers into our meta study. Like I was looking at concussion data, remember earlier in the semester on rugby, right? And there's a meta study that listed concussion rates by high school sport, and in one of them rugby had the highest, and the other one rugby had the same as everything else. And I was like, cool. And so I read through, because you have to read the primary sources, right? And so I read through the paper that showed that rugby had the highest, like far and away the highest concussion rate of any sport, and I go through it, and it's a meta study, right? Which means it's based upon lots and lots of studies. And so the meta study, I'm going through it, it's like we only found one paper on concussion rates in rugby that we included. And I was like, that's not much of a meta study, you know what I mean? Like, it's just, you're just reprinting the results of somebody else. Like the whole point of a meta study, bros, you're aggregating data together, and and so like, what is it? Does it have a high concussion rate or not? I don't know. And literally, I'm not like being a professor here. Like I literally couldn't figure it out from looking at the data. So, all right. So Kuhn's argument is that rather than this notion of science is sort of always progressing, he says that we have what's called a paradigm, that we view things in the natural world through a certain lens, like a certain frame, right? Like, for example, we believe that phlogiston exists, and phlogiston is some sort of mysterious fluid that allows fire to happen, right? And you do experiments, and you can conclude, look, if you pour phlogiston from a burning fire into a non-burning bit of wood, it'll pour like fire, water, or like liquid or something, And then other people are like, no, there's no such thing as phlogiston. Look, I've done an experiment. It's actually this thing called oxygen instead. That's the mysterious missing ingredient. If you pump out all the air, then the fire goes out. And so what happens, he argues, is that we've got a paradigm, and then you start doing research, right? And you start doing research, and you start building up evidence for the paradigm and against the paradigm. And every time you get a paper that is against the paradigm, he calls this an anomaly. And if the number of anomalies build up too big and too strong, then you have what's called a paradigm shift, or a scientific revolution, in which suddenly we switch from one model of viewing the universe to another. For example, if you talk about astronomy, we had a geocentric view of the world for a long time, right? That the Earth was stationary, that the sun and the planets revolved around the Earth, right? And so over time, we gathered information about the planets and things like that, and some data, you could explain using the geocentric model. In fact, a guy named Tycho Brahe proposed this epicycle model of geocentric that actually matched the movement of the planets actually pretty well. But what happened was, Galileo observed the moons of Jupiter, and you could see that there were these things rotating around Jupiter, and Jupiter is rotating around probably the sun, not us, And there's a whole trial of Galileo that we can get into that is widely misunderstood. The upshot, though, is that there was a revolution, and then a guy by the name of Copernicus, actually, who developed the idea that Galileo is perhaps more famous for, proposed a heliocentric model, that the sun is stationary and everything rotates around the sun. And then that didn't turn out to be entirely accurate, because Galileo and Copernicus's model involved a stationary sun, and it turns out the sun's actually moving around the galaxy, all right? And then Einstein came around, and turned out both geocentrism and heliocentrism are equally right and wrong, which is to say there is no such thing as absolute position or speed. It just is, you just pick a frame of reference. And so if you pick the Earth as a frame of reference, congratulations, Ptolemy is correct. If you pick the sun as a frame of reference, then Copernicus and Galileo are correct. And that's something that blows people's minds, which is like when you do a physics equation, you don't include the rotation of the Earth into it, because you're using the Earth as the frame of reference, right? And so, Tycho Brahe with the epicycles, if you want, you can make the Earth the frame of reference for the solar system, and it'll make all your math harder, which is why we use the sun as the stationary frame of reference for doing, Mars transfer orbits and things like that. But, they're actually pretty much equally correct under relativity. And so that's something that people like their heads explode, because the sun's the center of the universe. Is it? No. It's really not. Where is the center of the universe? Everywhere. Every point, in fact, is the center of the universe. So, people who said that Earth is the center of the universe are correct. People who said the sun is the center of the universe are correct. It's all the center of the universe. So, So the yeah, they're all wrong or they're all right. It depends on your perspective. But we had these shifts. We had the Copernican revolution, right, where all of a sudden people went from thinking that Ptolemy and Aristotle were correct about science to Copernicus and Galileo being correct, and then a couple hundred years later after that, Einstein overthrew all that. And it's not like when Einstein published his paper, it was just like, everyone's like, oh yeah, you're right. No, not at all, right? Like, people wanted to see experimental evidence that Einstein was correct, that gravity is curvature of space-time, before they, like, rewrote their textbooks. You know what I mean? So, a guy by the name of Sir Arthur Eddington, I believe, went and viewed a solar eclipse or something and saw light bending around the sun. I don't know. I don't remember the exact experiment. Basically, after people gathered experimental evidence for relativity, they're like, okay, you're right. You know? And so that's called a paradigm shift. A paradigm shift is when the old theory gets thrown out, the new theory comes in. And then, we've had, relativity as our dominant paradigm for, almost 100 years now. And the trouble is we also have quantum mechanics, right, as our dominant paradigm. So we use relativity and general relativity at the big scale, and we use quantum mechanics at the small scale. But the two theories are actually incompatible. They actually don't work with each other. So we know one of them is wrong. We don't know which one. So, it's one of the big, Yep. If you substitute in the relativity equations and quantum mechanic equations together, the math explodes. You get like divisions by zero and things like that. So yeah, we know one of them is wrong because they're incompatible. We don't know which, and so that's, you might have heard of the quest for a unifying theory. The grand unifying theory that'll unify quantum mechanics and relativity, and that's currently like the big quest. It's like the biggest open question in physics right now. So yeah, you can read more about that if you like. Science is interesting, and just studying science is interesting. So yeah, there's a whole field called philosophy of science, which is just studying how science works. How do we go about deciding what is right and wrong? Because we're living in an imperfect world with imperfect knowledge, and so we just have to do the best that we can, given the data that we have. And that's one of the things that people don't understand about the Galileo affair, where Galileo was put on trial. You guys remember that? The trial is typically the only example pointed to by people who say that science and religion are in conflict. They sometimes point to a guy by the name of Giordano Bruno also. And they're just wrong about that one. Bruno was a heretic who was burned at the stake for heresy. It had nothing to do with science. So the fact he had ideas of people living on other planets had absolutely nothing to do with the reason why he was burned at the stake. He was a heretic. He didn't believe in Jesus and all that, and he wanted to be a priest anyway. And the priesthood had issues with him calling himself a priest when he didn't like Jesus. So. Yeah, Galileo is really the only example that people ever talk about when they talk about the conflict, this supposed conflict between science and religion. There's something called the Draper-White thesis, or the conflict thesis. It's all psychology of science as well. And so basically, yeah, the Galileo affair is basically the only example that people keep coming up with, and yet somehow there's this popular perception that there's this eternal and ongoing conflict between science and religion, which is like historians don't believe the Draper-White thesis. Like the people who promote it are typically non-historians who just have an axe to grind, really. As far as the Galileo affair occurred, like what happened, Galileo published some papers attacking Aristotle and Ptolemy, which, at the time the Renaissance was very much about Aristotle. Aristotle was called the Sublime Doctor. He was considered the smartest man ever to live. And to be fair, Aristotle was a pretty smart dude. He did get a lot of science wrong, though, but he was a smart dude. And so Aristotle said that everything has a tendency to move towards the center. Like, that was his ethics. Like, if you guys remember how we talked about the notion that you shouldn't be too brave or too not brave, right? You should find the golden mean. That's Aristotle. You should move towards the center, right? That's Nicomachean ethics. It's one of the things you're studying in class this semester, And so when Galileo attacked Aristotle, all the Aristotelian scientists, they were called natural philosophers back then, they came after him. They came after Galileo. And Galileo was what you would call a troll these days, right? He was somebody who did not have that sort of humble, let's try to work together to figure out what's truth attitude that a lot of scientists have. Not all scientists, a lot of them today are pretty egotistical too. But he was just like, no, F you, F your mom, F everybody who disagrees with me, I'm right, you're wrong, you can all suck it, And he was intensely low charisma. Like, he had the ability to piss off, like, literally everybody. Like, the Pope was his friend, right? The Pope was his friend. And he pissed off the Pope. Like, it's just... if you read his letters to other people, he's just an absolute asshole. He just really is. And so he managed to piss off his fellow scientists, and so the scientists just decided he was wrong and needed to be checked, and so they got the church involved to adjudicate a scientific dispute, which is probably a bad idea, as the history shows it's a bad idea, but the church adjudicated it for a couple of reasons. The first was astronomy was important to the church because it was used to determine the date of Easter, right? Because Easter is based on the equinox. And so the Vatican has actually maintained an observatory on a nearby mountain since 1582, right? So, it's not like the Catholic Church was like, oh, science, burn them at the stake. Like, they've been maintaining an active observatory for 500 years. So, what happened was the church was brought in to adjudicate this. The natural philosophers said, like, the Bible says you're wrong. And so the case was judged first on the scientific merits, and then secondarily on the theological merits. And what the church found, they brought in experts and all this kind of stuff. They're like, we can't tell right now who's right, who's wrong, right? So we're going to judge it on the theological merits, and Galileo's wrong on the theological merits. And then he was told, you can continue researching heliocentrism. It's fine. Just don't tell everybody it's true until we have enough evidence that it's true, which is a completely reasonable thing to say because that's how science works. Don't overstate your case. Don't claim that. Don't claim more than what you can claim. And so Galileo's theory had a number of very serious and irresolvable at the time problems. The first problem was the issue of tides. If the Earth was swinging around the sun, the water would swing around as well. Because you have the Earth spinning, right? And so what you would see, if Galileo was correct, was one tide a day. And there wasn't. There were two tides a day. Pretty big issue. And so Galileo's response to this was to go and forge tidal data. He went to the ocean and literally forged data. Because he knew he was right. And so he forged tidal data showing there was one tide a day. And everyone's like, dude, we have boats. There's two types. Like, you can't, like, why would you even lie to us about this? Like, this makes no sense whatsoever. And so Einstein called that Galileo's greatest mistake, which is kind of putting it mildly. Yeah, like if you're a scientist, like you don't forge your data to make your conclusion, right? It's the opposite of how science is supposed to work. You're supposed to make observations and draw conclusions from it. And Galileo's like, nope, I'm right, and so I'm just going to forge title data that everybody knows is wrong. It's just dumb as hell. There's the parallax issue where, like, when you move around the sun, if you do this with your head, you can see, like, my bookshelf. I'm looking at one side of my bookshelf and the other side of the bookshelf. The argument was you would see the stars doing that, right? The stars would shift in the sky during the year as the Earth moved around the sun. In fact, they do. It's just small enough that they couldn't detect it at the time. And so Galileo didn't have any evidence for parallax. There was the issue of, if the Earth's spinning, why don't you sense the sensation of spinning? If you're on the outside of a ball that's spinning, you should, the Earth's big, it's moving fast. Why don't you detect it? And so, all these have been resolved by science, right? Like we can actually detect the force of the Earth spinning. We can see parallax. He just didn't have evidence at the time for it. And so what the church said was continue researching it, gather your evidence. You can write a paper on it. It's fine. Just don't say that it's settled science, because it ain't. And so then Galileo wrote a book which he claims wasn't designed to troll people, but he trolled the Pope. So got in trouble for violating his agreement. He was friends with the Pope. The Pope had come and had looked at the moons of Jupiter through Galileo's telescope. Like he was like sympathetic to the view. He's like, yeah, sure looks like it's heliocentric, and people argue to this day, was it deliberate or not on Galileo's part, but he basically called the Pope a simpleton. And so he wrote the dialogue concerning two world systems, and he had the smart, witty guy explaining heliocentrism, and he had a person who's an idiot called Simplicico, which means simpleton, writing the case for the geocentric model, and put words that the Pope had said in the words of Simplicico. And so the Pope was like, oh, hells no. And so he got hauled back. There were actually 2 trials of Galileo. And he got hauled back for basically violating the terms of his parole, which was, and he's like, look, I presented a dialogue. It's 2 people presenting 2 different sides. And everyone's like, yeah, when you make one side, when you make it completely lopsided, and one person presents all their facts, and the person's like, I'm an idiot, I don't know what I'm saying. Like, that's not, we know what you're doing. Like, we can see through your deception, Galileo. And they hated him for telling the truth. Yeah, that's funny. That's a good meme. And so the Galileo, the Galileo affair is widely misunderstood and widely misreported as just, a church being opposed to religion. And to be fair, the church, as the result of Galileo being a troll, put Copernicus, who had written like 80 years earlier, you have to understand, like, heliocentrism had been out for a while, right? Like, Copernicus dedicated his book to the Pope. It was widely read, no issues whatsoever. Because when you're not a troll, you don't piss off everybody. You know what I mean? Like, it was fine. Like, people have found copies of Copernicus all over Europe, and people were, there were marginalia where people taking notes on it. Like, everybody in astronomy was reading Copernicus. It was not a big deal until Copernicus is like, F you, F your mom, F your dog, everybody, burn in hell, and he basically took Copernicus out with it. And to be fair, the Catholic Church did add Copernicus's book to the banned list. They basically banned Galileo and Copernicus for like 200 years, 300 years, something like that. So even after they knew that it was more correct than geocentrism, it was still on the banned list just because, just because. So Yeah, so that, I mean, it's a fair criticism. Like it's like, if you want to criticize, the Catholic Church on the matter, like, yeah, they probably shouldn't have been adjudicating scientific disputes, for one thing, and two, they probably should have unbanned him a little bit earlier. But they were kind of mad at Galileo, so it's like, it's it's not a good thing, but it's kind of understandable, why why it shook out the way that it did. So so the other big thing is understanding kind of like what the scientific method is. So we think, like, have you ever seen these posters before, like when you were in middle school or something, like your science teacher would have a poster for the scientific method up on the screen? Yeah. So you ask a question, state a hypothesis, you conduct an experiment, you analyze the results, make a conclusion, do it all again. All right. Okay, what about this one? What about this scientific method? Write down your problem, write down your materials used, write down your hypothesis, your procedures, your results, and your conclusion. Right? If you actually do a study of middle school science method, scientific method posters like I have, you'll see, like, they're all different. And the reason for that is because there is no such thing as the scientific method, right? Like, this is another thing that Kuhn talks about, which is that the scientific method is whatever it is scientists do. It's not that they're a lie exactly, but like, if you're working in a lab, which I've done before, do you think they sit down and say, all right, what question is it? Step one. No, like you're investigating how cardiac heart cells work. Like, what your question is. You don't even really have a hypothesis as such. Instead, what you do is, like, you'll run experiments. Like, all right, if we drive a heart cell at 30 hertz, and then we up it to 60 hertz, it skips beats. Okay, cool. Let's see if we can quantify this and make a model of it and determine how quickly heart rates can change without skipping beats. And you do experiments and you do results, you analyze them, and you have conclusions, but they're all sort of jumbled together. You know what I mean? Like, it's not like we're like, what question are we going to ask in the cardiac research lab here? We're researching cardiac, like, we know, and we don't, what materials do we have? Like, let's look around the lab, like, we got all this stuff, like, like, we had severed rabbits' hearts. So, like, there was like these spikes, and they would put a rabbit heart on it, and there were wires coming out of it. It looked like something out of Frankenstein or something. They'd sit there beating, and they'd drip this, like, fluid over it to keep it alive. It had, like, oxygen and nutrients in it. And so they'd sit there with these wires, and the little rabbit heart would sit there beating. Just out on somebody's desk. Yeah, it's interesting. So yeah, true story. We kept the lab locked at all times because they were worried that PETA would come in and, like, see these, like, severed rabbit hearts just beating, on a stake, and, like, get upset about it. So yeah, I did. You had to use a password to get into the lab. Yeah. Forbidden lollipop. Yeah. Yeah. But, like, there was none of. I mean, we did science. Like, it was like we were the number one bioengineering department in the world at the time. And by we, I can't take credit for it. I was just, essentially a computer scientist working for them. But it's not like I was doing the science. I was supporting it. I don't know the right. I mean, I guess it was science. I don't know. Who knows? I was part of. So they make models of how the heart cells work, and then the models were for, like, these weird and obscure computers, and I had to port them to other things. And so, I was sort of vaguely involved in science. I don't know. Who knows? But the thing is, like, none of this. Like, you know what I mean? Like, we were doing science, but it wasn't like the way that middle school tells you. Like, we would gather data and write a paper on it, and you would write papers a couple times a year, and get them published and things like that. But it's not like, let's ask a question, So, and also different fields of science don't all follow the same steps all at the same time. Like if you do astronomy, you can't like make a black hole, or have our sun go nova or something like that. Like you just can't. Like you can do observations of the heavens and see when a star goes supernova, but you can't like do it in a lab. You know what I mean? And if you're talking about like psychology, yeah, like sometimes you can go like, all right, let's measure the priming effect. The priming effect is if you say words like old and arthritis and crippled and hobbled and things like that, you say those to students, you let them walk down a corridor, do they walk faster or slower? And that's to measure the priming effect, but it's not like you can put your kids into a beaker and like, shake them up. And it's also the fact that in psychology, it's almost always college freshmen that you're running your experiments on. And so whether or not it generalizes to the population is one of the big, Achilles heels of psychology, because pretty much all we know about is the college freshmen. They're the lab rats of science when it comes to psychology, And so whenever you see a paper come out and say Americans are drinking heavily and sleeping around, it's like, are they, or are you just talking about college freshmen? Because can you generalize to the population? What population group do you have? So you're part of the experiment when you're a freshman. Yeah, it's freshmen are they're the lab rats of psych, right? It's basically a thing like when you take a psych class, you have to participate in experiments. What if you put children into beakers? It's funny. So yeah, all right. So the big stuff that was left out, by the way, on both those posters was replication, right? So a huge part of science is replicating somebody else's work, right? So if somebody comes out and says the priming effect is real, if you say words like sprightly and energetic and marathon, people walk faster down a corridor, and if you say old age, geriatric, things like that, they walk slower. A big part of science is replicating. So you do the experiment at your school and see if you get the same results. And as it turns out, they didn't. So everybody knows about the priming effect in psychology, but when they tried replicating it, it didn't work. And so the people who came out with the original priming study said, oh, you didn't replicate it correctly. And the people said, well, it doesn't matter if you replicate it correctly because we made our own experiment, and maybe there's things more interesting than walking down a corridor, and they go back and forth and back and forth and back and forth. But here's the really scary thing, which is in 2015, about 6 years ago, these authors who are psychologists replicated 100 of the most famous, most important, most widely cited, most influential psych papers. Okay? So out of the 100 papers, which percentage of them would you guess successfully replicated? And these are the things that people take as truth, right? Like, left brain and right brain, are different. And, the Sapir-Whorf hypothesis, the notion that the words that you learn control your reality, right? Have you guys ever heard that before? Like hospitals don't, like this one hospital doesn't allow you to use bullet points like I have here in my presentation. You can't use a bullet point because bullet point is a word of violence. You can't use bullet points because bullets are violent. And so if you use a bullet point at our hospital, you'll be fired. You have to use numbered lists. You cannot use bullet points. Yeah, and that's called the Sapir-Whorf hypothesis, which is the notion that language controls reality. Yeah. Self-driving cars were put on college freshmen too. Yeah, 20%, 1%, 3% out of the 100. No, you guys are all very pessimistic. Huh? So 39 could be reproduced. And you have to understand these aren't like random papers. These are the top papers. These are the best and most influential and most cited papers, and they can only reproduce 39 of them. So, and I use bullet points anyway, yeah, because I think the Sapir-Whorf hypothesis is mostly nonsense. There's a certain degree of truth to it. Like, if you say words like, "Hey, the finals tomorrow," there will be a collective rise in the stress of students. But if I were to change the name of the final to a quiz. I don't know. You know what I mean? Like, it's not going to... Like, the superior wharf hypothesis is grossly overstated as well. And it's probably a myth, too, depending on how you formulate it. Less than half. Yeah, now that's an issue, right? Because that means that if these aren't random papers. These are what everybody thought was true. If you flip a coin, you have a better chance of being right than if you believed one of these papers. And that's a problem. Because that means you could flip a coin to determine if you should believe a paper. Now, that's really, really bad. Because all these papers are supposed to have significance degrees of 95%. So all of these papers, in general, were published with a p-value of less than 0.05, which means there was a less than an 0.05 or 5% chance that the results were due to chance. So out of all these papers, and they were heavily cited, but as it turns out, just nobody bothered checking to see if they were actually right or not. And so this is really, really bad. And so it's actually caused a crisis in science, which is like, what's the point of doing science if you could flip a coin and be more accurate? Right? All right. I guess heads. I guess orange juice does cause cancer. That's horrible. Yeah. That means you're not really doing science at all, right? Because the whole point of science is to statistically approach truth, to be confident that within, plus or minus 3%, you know something, right? And some people say, well, it's just because it's psychology, and psychology is kind of a loosey-goosey science. So the American psychology, if you know APA formatting, right? They defended their field saying, well, other fields have a problem too. Which fallacy is that, by the way? It's not just us. Which fallacy is it? Well, medicine has the problem too, because medicine actually does have a big issue with replication. You too, yeah, too cool quote. Right. So, too cool quote. Right. Well, you do too. So, why? Why does this happen? We've talked about this before. The publisher-perish mentality in academia is toxic. It's highly toxic. The tenure process is oftentimes toxic as well. A friend of the family got tenure at USC only after the most bitterest and longest of fights with his tenure committee. They did not want to give him tenure. And he was publishing papers left and right, groundbreaking papers. They just didn't like him. And so he fought tooth and nail to get tenure. And like we talked about this before, if you don't get tenure, you're thrown out on your ass, and good luck getting another tenure track position, another institution, a lot of people, it's their life stream to become professors, and it's really, really tough to do so. Fortunately, my tenure process was basically, good job, keep it up. It was, after hearing about all this stuff this guy went through, I was like, wow, you guys are really nice. Yeah, like, we love you. Keep doing what you're doing. You're doing fine. So you have to go. Yes, yeah. We're meeting Wednesday and Friday. Yeah. So, yeah, and so in academia, the paper is sort of your health bar, as it comes to academia. And the more papers you publish, the bigger your health bar, right? The more you can survive the tenure process. There's also grants, right? And this thing I went to with Duke University over the spring, one of the people came in, they said, a new professor has to bring in $1 million of grants or we fire them. You've got 4 or 5 years, but you've got to win grant after grant in order to, or one big one, I guess, in order to make tenure. And so it's an incredibly stressful and punishing process. Maybe, at least, yeah. It depends on your institution, really. But yeah, there's this huge pressure to push out papers and to have good papers that are published. Interesting, groundbreaking results, it's huge. And if not that, then just shovelware. Just produce incremental papers left and right. Whenever I do peer review, I tend to shoot those down because I find incremental papers to be utterly boring. Like I read one this last year that was basically their notes from meetings, pre-meetings to determine a like there's like they didn't even do anything. Like they were just like meeting to like talk about putting together a history of computer science or something. I don't know, but they didn't actually do it. The paper actually didn't say anything about the history of computer science. It was just like we met and talked about it, and we laid down rules for how we would go about determining the history of computer science. And I'm like, you didn't even put down what the rules are. Like, none of this is useful. And so I've, all this like with, it's like the, in Gladiator, oh, sorry, I have to do it on screen. The Joaquin Phoenix thumbs down meme. And so, yeah, like peer review could be tough too. And so you've got to, not only do good papers and write a lot of them, but they also have to pass peer review somehow. It's very stressful. So, yeah, see you, Tom. That's cold. What was cold? Me turning him down? Like, no, I absolutely detest shovelware. Like, hey, we met 3 times and didn't do anything. Like, why would you waste somebody's time reading that? You know what I mean? Like, why would you waste my time reviewing it? And if I published it, hundreds and hundreds of people are going to read this paper. That's an utter waste of time. So so that's called the Replication Crisis. Negative findings don't get published, and then they'll shop around, and so if you don't get published at the good journals, they go to the tier 2 and then the tier 3 journals. They keep shopping it around until it gets published. I hate incremental work. Sometimes I guess there's value to it. Like, you have preliminary results that are very exciting, you want to share them, okay, sure, but don't publish your meeting minutes as a research paper. And then science journalism will typically look at all these preliminary findings and then report orange juice causes cancer, and science reporting is almost universally terrible. I'm pleasantly surprised when I actually see science reporting done correctly. Like, if you think that reporting's bad when it comes to anything political, like, it is. But like science reporting is it's really bad. Like when I see somebody actually get the just the minimum requirements. Like, what is the effect size? What is the p-value? Don't have a clickbait headline. Like, if I just see them get the very minimal basics correct, I'm just like, it touches, like, my heart, my soul has opened. Like, oh my gosh, you actually have done a good job, and you've linked to the primary sources, and there's interviews, and in the interview, the scientist says, be aware, this is a preliminary finding, it's not a final finding. It's like, it's the Robert Downey Jr. meme, like, wow, you actually did your reportage correctly. Amazing. Almost always disappointing. I sent my CSI 26 students on a quest to find a well-written science journalism article. And they're like, man, this is hard. All you have to do is find one. Just find one paper, one new blog entry, whatever, that, just one. Just find one that's well-written, that just meets these, just no clickbait, effect size, p-value, cite your resources. That's, like, just the bare minimum that, like, we require from you guys when you're doing your essays and your research. Just find me one. This is difficult. If you on any topic, all right? Let's see. I know we're done. But let's see here for you: U.S. World, Fresno, business, tech, entertainment. Let's see, sports, science. Okay. Stunning photos. Yeah, that's clickbait title. What is that? Clickbait title. Mysterious hut. Clickbait title. Watch NASA announce its next astronaut class in its webcast replay. That's not even science. It's vaguely science related. More science. Here we go. Let's see more science. After a thorough review, they awarded additional astronaut flights. It's not science either. That's just an announcement. Vaguely science related, I guess. Okay, yeah, this one made the rounds a couple days ago. Self-reproducing robots. And there's almost guaranteed to be no p-values and things like that in here. Yeah. Nope, of course not. So, yeah. It's hard. Yeah. My boyfriend refuses to divorce his ex unless I paid for it. Is this why is this a science article? Why are you in what is this? Why is this tag science? All right, 2 hominid species. All right, that looks like science. All right, here we go. Ars Technica. Okay, so at least it links to the Nature article that they're citing from, but it doesn't work. I guess I tried. I got you. I was about to get so excited. At least, even if you don't have it, like, look, they at least have Latin names or something, and the link doesn't work. Sad. Okay, that's it for today. We'll leave on a low note, I guess. I just don't know. Yeah, why would there be an article on divorce? Like, is this an experiment? Was it a psych experiment or something? Is that why it was in the... Or it was probably mistagged, but it was just... Why are you in the science category? Now this is an Avengers level threat. Yeah. Just trying to find just one, like, just minimum, like this. Like, I don't even. It doesn't even need to be like exciting or anything. Just need the minimum, things. Like when I took a science writing class, right, which is maybe one of the reasons why I'm picky about it. But it's like if you would get an F on it in like a freshman level science writing class, like why is it so hard to find? I don't know. No. All right. Well, that's it for today. So I hope that was at least amusing for you. Keep an eye out for that when you're reading science, stories. Always take it with a grain of salt, and the headlines are there to get your clicks, not to educate. All right. Peace out. Bye. Thank you, Google. Very cool.